To start. So welcome to our presentation and discussion on the springs of New Jersey. My name is Mara Tippett, Associate Director at Raritan Headwaters, and this presentation is part of the Raritan Headwaters Watershed Tools for Local Leaders seminar series. And the recording will be posted on our website where you can view this and many other informative webinars we've presented in this series. The goal of the seminars is to provide expert level knowledge and understanding through interactive discussions, take-home materials, and hands-on planning activities. Workshops are presented by Raritan Headwaters scientists and policy experts, as well as visitors from regulatory agencies, universities, and other nonprofit organizations. In addition, participants and presenters learn from one another's experiences and find ways to partner on projects to protect and restore water resources. Please use the chat to introduce yourself and tell us where you're logging in from, and if you're here representing a municipality or organization. And we'll take questions after the presentation. If you'd like to post a question in the chat, or you can request to be unmuted, raise your hand and you may ask the presenters a question that way as well. So I'm excited to be learning more about springs today and that we have so many people joining us this afternoon. Springs play a vital role in the hydrologic cycle and the health of our watershed and provide a window into the earth, which allows for observation of our hidden aquifers. These ecosystems support more than 20% of the endangered species in the United States and are some of the most sensitive indicators of climate change. Springs also hold great cultural significance for many indigenous cultures throughout the world. Until recently, very little research has focused on springs ecosystems, and many springs remain unmapped. Conservation organizations such as ours, municipalities, and landowners cannot protect these ecosystems without first knowing where they are. I'm going to post a link to the Springs of New Jersey paper in the chat if you're interested in reading the study in its entirety. And there is a lot to cover, as I said, in a short amount of time. So I'd like to welcome our presenters today. Rachel Philo, environmental scientist in the Bureau of Water Allocation and Permitting at DEP. Steve Domber, Section Chief for the New Jersey Geological and Water Survey, DEP. Ted Pallas, GIS Specialist, also New Jersey Geological and Water Survey, DEP. And Yari Acosta Caraballo, PhD candidate at Montclair State University. So welcome everyone. I'm looking forward to seeing what you've brought to us today. And just let me know as you'd like me to move forward. Of course, I'm hitting my arrow button. There we go. So far, so good. Okay, take it away. Thank you so much.
Hi, my name is Ted Pallas. I work at the New Jersey Geological and Water Survey. And I want to talk to you, we're going to talk to you today a little bit about a project we did on classifying and identification of springs in New Jersey. This is on the image there is the title page of our report. It's on our website. And also the authors of the report are listed here. Next. Our project including mapping the location of New Jersey springs, collect a water sample from 14 selected springs and analyze a sample in laboratory with parameters including general chemistry, metals, microbiological, pesticides, radon, and VOCs. We took limited on-site water quality readings from the 14 same springs for 1 year. We try to do a comprehensive, holistic approach to each spring that we researched, the 14. Included discharge, temperature, geology, ecology, flora and fauna, aquatic life, and microinvertebrates. We published all this information in a report. It was published in this past September. And we also developed a relational data GIS database of springs, and it's available on NJDEP Open Data webpage, which you can see the link there. Next, please. For project history, we began in 2009 through 2016 by mapping spring sites. but it's still ongoing when new springs are added. Were added when we find them. Springs database was developed from the information collected from maps, site visits, etc. In 2014 is when we did the ecological integrity assessment of the headwater wetlands near springs, the aquatic vertebrate study, and microinvertebrate study. In 2014, we also collected water temperature for a year at 14 selected springs. Next, please. So as you can see on the map on the right, we mapped 511 springs, the black dots. We visited 65 springs, and we sampled 14. Next, please. So why study springs? Until now, little information has been systematically collected about springs in New Jersey, despite their historic, economic, geologic, and environmental importance. To understand the significance of springs, they must be located and comprehensively characterized and classified. And the picture on the right is from the Sperry Spring in Lake Apacong. Unfortunately, due to development, the spring has been lost to history, but it was once a popular spot on Lake Apacong. Next, please. Quote from Oscar E. Meinzer, often called the father of modern groundwater hydrogeology, in his publication Large Springs in the United States, published in 1927. So what are the largest springs in the US? How much water do they discharge, and what geologic conditions produce them are questions of much popular interest and considerable scientific and economic importance. Yet the information in regard to large springs has been so widely scattered and difficult to interpret that most people have only a vague notion on the subject. The same could be said today about New Jersey springs. Next. I just want to talk about some spring attributes. Springs are some of the state's most valuable natural resources. They provide unique sources of clean and plentiful water. They're known to have unique habitats and historical value, and they're relatively small compared to other water features, though they support 20% of endangered species in the US. Next. Some early significance of springs in New Jersey. They were been the focus of human settlement in New Jersey dating back to Native Americans. Their village campsites and hunting area locations were often near springs as they were attracted to good spring water. They also recognized the curative properties of some springs, including the Schoolies Mountain Chalybeate Spring in Washington Township in Morris County. T.D. Sung, the renowned king of the Lenni Lenape, is said to have always kept his campfires burning within 3 miles of it in order he might resort to it at any time. Later European settlers were drawn to springs, thus communities in New Jersey grew around them. Next. Springs were also important during the Revolutionary War. They provided an important source of drinking water to soldiers during the war, and George Washington's troops were known to have drunk from numerous springs in New Jersey. Two in particular, Battle of Princeton, there was a spring located along 206, and his troops stopped there to get some water in 1777. In the 1780, Continental Armor was perhaps utilized waters at a spring in River Edge in Bergen County during one of his encampments. A plaque on the right here is commemorating Washington being at the spring. Next, please. So there's also the Molly Pitcher Spring in Monmouth County. It's very famous. The story of Molly Pitcher during the Battle of Monmouth in 1778. She carried water from a spring to thirsty troops on a 97-degree day. The next day, she took over firing the cannon after her husband was wounded, though this has never been proven. It's part of her legend. Today's spring is known as Preen Hill Spring. It's lower right picture. You can see the source of it. And on the top picture, there's a plaque commemorating Molly Pitcher. Next, please. So back to the Schoolies Mountain Spring. It was the most famous spring in New Jersey at one time, utilized by many people dating back to Native Americans. They tried to keep it a secret. The early settlers discovered it, and then they built the spring house you can see on the picture on the right. It was also responsible for helping to create one of the first summer resorts in the United States in the 1700s. Next, please. The Schoolies Mountain Spring, unfortunately, another one became a victim of road widening construction in the 30s and has ceased since to flow. You can see the before and after pictures of what the area looks like. Next, please. New Jersey has quite a history of mineral springs. If a spring is thought to have therapeutic value, they are often called medicinal or mineral springs. Purported beneficial effects have been known since antiquity. There are numerous mineral springs scattered throughout New Jersey, and Chalice Springs iron springs were the dominant type of mineral springs in New Jersey. On the map on the right, you can see they were scattered throughout New Jersey. Next, please. Bottled water became important in New Jersey. The first bottled water company was the American Spa Spring Company in 1866, also known as Woodbridge, Chalaby, or Ironwater. You can see their advertisement from a local newspaper back in the day. Next, please. A little bit about bottled spring water history in New Jersey. As the mineral spring resorts and spas were waning in popularity during the 1800s, bottled spring water was in great demand. At the turn of the century, there's a growing belief that the surface water many cities use for their water supplies was contaminated. Springs were considered a practically guaranteed source of safe to drink water. The bottled mineral and spring water business would slowly taper off after the 1920s in New Jersey, as many towns started to chlorinate their municipal water supply. Jersey City was the first municipality in the United States to chlorinate the water supply in 1908, and shortly after, in the next 10 years, it caught on in many other areas, and it became a way of disinfecting water. By 1990, the bottled spring water business slowly started to grow again in the United States and New Jersey. Now it's $1 billion business in the country. Next, please. As of 2019, 8 companies provided spring water from New Jersey for bottled spring water, and you can see the list on the left here. And on the right is the manufacturing plant next to the spring for the Belmar Spring Water Company in Bergen County. Next, please. There are some public drinking water springs in New Jersey, not a lot, but a handful. Water is available to fill your own jugs, as this one on the picture on the right is from Thompson Park Spring in Jamesburg, but they're usually posted at drink at your own risk because they're not treated and susceptible to contaminants. Next, please. Fish hatcheries were a big industry in the 1800s that utilized spring water. Several fish hatcheries located adjacent some of the highest discharge springs in the state. The right is the Muskie Trout Hatchery in Asbury, Warren County. It's fed by the Stanley Spring. Another hatchery is, the New Jersey State hatcheries, fish hatcheries in Hackettstown and at Pequest also use spring water for their fish. Next, please. So the Stanley Spring at one time back in the 1860s was called the Troutdale Spring, when it was first started as a fish hatchery. It has a steady 51-degree temperature, which is ideal for spawning trout. The spring had its flow measured longer than any other spring in New Jersey. First measured in 1868 at 1,000 gallons per minute. In 2012, it was measured by the owner and had a flow of 1,200 gallons per minute. And like most springs in New Jersey, its flow has been variable over time. Next, please. So next, we're going to move on to a discussion of Upper Raritan Watershed Springs. I'm going to pass this on to my co-author, Rachel Philo.
Hi, I'm Rachel Philo. I'm going to talk about a little bit about part of our case study. So many springs were mapped in the Upper Raritan Watershed, and it's outlined by the light blue line on the map. One spring in particular is at the Valley Crest Farm Preserve in Clinton Township, and this was monitored and sampled as part of our statewide spring study during 2014. Next slide, please. So just a little brief overview of the geology of the area. You can see where the spring is located by the little water droplet icon on the map. As Within the Allentown Dolomite, it's also near to the Leesville Formation, which is also contains a lot of dolomite. And if you could see a little bit upstream near where it says the Kramer's Creek Spring, there's that other light pink color, and that's actually also a limestone formation. So with limestone and dolomite, they all have, they're all made up of calcium carbonate. So that, especially in New Jersey, is usually reflective in terms of a sedimentary structure, as it was formerly a shallow water environment. So it has the calcium carbonate from a lot of shells and former coral reefs and stuff like that. So the important part of this, I guess, is that with limestone and dolomitic springs, they might be more susceptible to contamination because it's more of a porous rock. And also sometimes maybe the water chemistry could be affected because it has limestone in it, which calcium carbonate could kind of create a more basic environment instead of being acidic. But it could also be susceptible to stuff like acid rain, which would wear down the rock to some degree. Next slide. So at Valley Crest Farm, there were 3 springs that were sampled. You can see some pictures of them right here. So with the springs, one of them actually had a spring house that we were able to go into, and they were near to each other and part of the farm water supply. And the spring water from the area is now collected in large amounts and sold as commercial bottled water. Next slide. Spring 1, which was sampled in 2014. The nitrate concentration in this spring was the second highest in all of the 14 springs sampled, and was one of the 3 springs sampled that had a detection for chloroform. Chloroform can be from anthropogenic or from natural sources. The low level concentration in the forest setting tentatively indicates natural sources for the chloroform detected. Next slide. Here is just quarterly field monitoring for 1 year that was done at the Valley Crest Spring 1 in 2013 for pH, conductivity, temperature, dissolved oxygen, nitrate, and phosphate. Just here you can also see in this table with the nitrates, how high they were. I think usually about 3 parts per million is considered pretty high. And you can see in July, it goes over that a little bit. So one of the sources of nitrate is from manure and stuff that comes off of farms. So its proximity to a farm could have something to do with that. And also in mentioning previously the geology being in around limestone formations and dolomite formations might have also affected what contaminants from the surface could have washed into the spring water and groundwater and percolated down. The pH is also, it's pretty neutral. It's 7. That's usually what water is. And I'm not totally sure. I don't have enough background knowledge to know if a lot of limestone springs are incredibly basic, but I do know that sometimes in testing you can find that some waters are a little bit more acidic, but with this water being kept at a pretty neutral level of pH might have something to do with the limestone and dolomite kind of balancing out any acid rain that might have percolated through and kind of helped to regulate it. Next slide. Here you can we have a Valley Crest spring water temperature comparison chart. So the graph below shows a comparison of long-term temperature variability from 3 New Jersey springs that we were looking at. One was the Marble Hill Spring, which is indicated by the blue line, and it shows fairly constant temperatures throughout the whole study period during the year. Valley Crest Spring is the red line, and you can see that it's more seasonally variable temperatures, and it's influenced by periodic precipitation events. And then the 3rd spring shown on this chart is the Dingman's Ferry Spring, which is up in Sanderson Township in Sussex County. And it shows a presumed combination of multiple influences. So that one's a little more varied. Next slide. Just going to do a brief overview of springs and climate change. Next slide, please. So just, this is in general, with global climate change and impact on springs, which of course can be related to New Jersey as well. Climate change can affect the flow and the water chemistry of biological aspects of springs, including in New Jersey. So a rise in temperature would alter the timing of the annual groundwater recharge cycle. And the temperature increases could also contribute to increases in precipitation volumes and intensity. So this could affect how much recharge is going into the groundwater, affecting spring flow, and also could affect contaminants that might wash into the springs and percolate down through into the groundwater, especially if the springs are close to the surface. Northeast New Jersey has undergone a 70% increase in precipitation during heavy storm events from 1958 to 2010. And warmer average temperatures with intense period of precipitation won't aid groundwater recharge the same as moderate average precipitation. So it's going to affect the recharge of springs. This chart that I have here is from the Office of the New Jersey State Climatologist, and it just shows the statewide annual precipitation. All the points are the statewide average, but the dotted blue line is the 5-year average of the data. It's a little hard to see a trend here. You can see, for instance, the big drought in the 1960s. You can see that dip in precipitation there. So it shows like a slight, I did plot a trend line at one point, and it does show a slight upward trend in precipitation, but it's a little hard to tell here. Next slide. Sorry, next slide, please.
Rachel, are you still there? Did we lose you?
Do you want me to take over for this one slide real quick? Here.
Sure. Sure.
Rachel, you there?
We may have lost her.
Okay, this is a summary of Rachel's work. This says climate change could also lead to changes in stream and groundwater temperatures. Though air temperature increases at a greater rate than stream temperature, small increases in water temperature could affect plant and animal life around springs, and higher temperature may increase physiological stressful conditions on fish.
Thanks, Ted. I got disconnected,
sorry.
but I just got back. Sorry about that.
You can finish up, Rach.
Yeah, thanks. I think that's about the end for the climate part of springs. We can go to the next slide.
All right, so good afternoon. My name is Steve Domber. I work with Ted and Rachel and Yari on this project. And I just want to sort of step back a little bit and give you guys some perspective on springs and characterization and how we think about them, at least in New Jersey. And so if you go to the next slide. So, Ted and Rachel gave you a good overview of the kinds of springs in New Jersey, where we find them, how they've been used historically, culturally, kind of thing. But if I put on my hydrogeologist cap or my scientist cap here and start to think about how we define a spring, how do we characterize them, it gets messy really quick. When you look in the literature, there's really no universal definition. There's no absolute, this is a spring and this is not a spring kind of work out there. It depends geographically on where you are. It depends on your expertise, your interest level, kind of thing. But so we were sort of forced to come up with a way to define these things in our sense of the world, kind of thing. And so generally defined as areas of focused groundwater discharge. They can vary in flow, volume over time. They can be located in lots of different geologic settings, at the base of a hill, on the side of a hill, underwater, into the ocean, freshwater into the ocean, or freshwater into a river or lake. And they can certainly vary by temperature and chemical variability, that, as Ted and Rachel showed in the previous slides. In New Jersey, generally smaller volumes. We tend to think of them as flowing year-round perennially, but certainly the sites that we looked at in a little more detail, we saw variability over the year. The water chemistry is reflective of the bedrock or the geology that's in contact with, And we definitely saw anthropogenic impacts, whether it's pollution or drying up from nearby groundwater diversions or land use changes, or they could be sort of covered over, constructed, destroyed, like the Schoolies Mountain Spring was, or they could sort of been trenched and sewered over as the development land use change over time. So, we have sort of a small subset of what you see globally in New Jersey. I like to say we're a small state, but we have it all from the mountains to the ocean. The same is sort of true for springs, although we don't really have the thermal springs that you hear about in some places. So next slide. All right, so again, sort of the geologic, O.E. Meinzer was a geologist, hydrogeologist, and so that was sort of one way of characterizing them from a geologic perspective. And this figure on the right just shows you sort of one way of looking at geology and geologic setting to define a spring. And so you have sort of depression springs, contact springs, fault springs, yada, yada, the whole 6 different ones there. What we realized from this work is that in some cases, it was really obvious. In some cases, it wasn't clear whether it was one spring or another or a combination of both. And some of them you just couldn't tell. We knew they were a spring, but we weren't quite sure what the geologic setting was, and we didn't have the time or the resources to do a deep dive and figure it out. But geologically characterizing springs was one of the first ways of thinking about sort of putting them into buckets and describing them. Next slide. The other way that Meinzer also talked about was sort of flow, the volume of flow kind of thing. And so they came up with these magnitudes of different springs. And this is one that sort of stuck around. You see it in various different units, depending on what table you're looking at, but just how does the flow, how big is the flow? Big, small, really small kind of thing. And then this report also talked about variability as well too. But it was really flow hydrology focused. So geology and hydrology are the 2 sort of initial ways that people thought is to think about them. Next slide. So here's just some examples of different spring, magnitudes in New Jersey, right? So Bonnie Brook Spring on the left, which is, I believe, the Paulinskill tributary, is one of the largest ones in New Jersey, but it's only a 2nd magnitude. So there are bigger ones in the rest of the, in this definition. So 5,000 gallons per minute, which is about 11 CFS. And then this is just one of the many small 8th magnitude kind of seeps or springs, depending upon who you ask. This might be a wetland seep, this might be a spring, but it's really small wet area on the side of a hill. And I don't even remember where this one was. It may have been up in the Delaware Water Gap National Recreation Area, but I'm not sure. Next slide. So again, here's the list of the big ones in New Jersey. So again, 2nd magnitude would be Bonnie Brook, and then the other ones here, 2 through 10, are the 3rd magnitude springs, so slightly smaller. So Bonnie Brook was, 11 CFS, so just made that 2nd magnitude. Schuster Pond right down the road. Ted talked about the trout hatchery, the Muskie Trout Hatchery Spring, and then Pequest, right? So a lot of the big ones were associated with fisheries and fish hatcheries. And then going down through the list there. So again, we have some bigger ones in New Jersey, not a lot, but we certainly have some that have been around and well known for a while in New Jersey. Next slide. Here's Brow Kettle. This is what we would call a sinkhole spring. It's variable, varies in flow and whether it's flowing or not over the year. And so, again, the could be as high as a 3rd magnitude, but it could be dry. Sitting on limestone, and that's sort of a schematic on the upper right there of how the water, recharges it to the ground and then comes out of the spring. And there's just a picture of it on the bottom left when it's full, and on the bottom right with it empty, kind of thing. So this one is up in the Delaware Water Gap, also, of interest, but one of the variable ones we see in New Jersey. Next slide. Indian Lady Hill down in Monmouth County, contact spring. So again, you've got a high porosity sand sitting on top of a clay, and the water infiltrates down, hits that clay layer, and then moves horizontally till it hits a hill slope, and where it sort of seeps out on the edge of the hill slope there. Very typical of that hilly area in South Jersey. You see springs like this. Next slide. Locust Grove up in Union County in the basalt. Smaller, but variable, probably flowing along the joints in the basalt and the rocks there. So it sort of recharges and hits these fractures and joints and flows down till it hits a spot where it comes out of the ground where there's enough focused flow and it discharges. Next slide. Marble Mountain, a little bit harder to determine geologically, but a joint or fracture string probably. It's at the base of a hill, and it's a larger flowing one. Interesting in that there's not typically, you don't think of marble, the geology marble as a spring driven. Usually the big springs are in sort of carbonate, rocks like Valley Crest kind of stuff, but this is one in the harder rock and of interest and been around and known for a while. Next slide. All right, so, but they're more, as I sort of alluded to, springs are more than just geology and hydrology, right? So it's just more than rocks and water. As Ted was alluding to, there's a lot of sort of cultural, references to them. There's obviously, wetland species. Yari will talk a little bit about the macroinvertebrates next. So there's a lot of different ways of looking at springs and how to characterize them besides just geology and water flow. And so when we started speaking to some of the people, there's not a lot of them doing this work out there, but the idea of sort of designing a database or a way of characterizing springs that allowed for different types of information. Geologic is very specific, it's map-based, it's scientific. Discharge is a hydrology flow measurement, but then you've got sort of cultural things, so whether it was a Native American or whether it was a spring bottling company or a spring spa resort of some kind, or whether it was a source for a local farm, right? There's needed different ways of capturing different types of information. And so we sort of came up with this sort of general construct that was very open-ended. So you've got the spring geographically itself, and then you've got these different attributes that you could associate, different kinds of data that you could associate with the spring. Some of them you would have for all of them, and some of them might not be relevant, or you might not know how to fill it in. But the idea was to come up with a schema. And if you go to the next slide, for you database geeks out there, this is what this database looks like. That sort of circular design with the main spring and the different attributes assigned to it. This is what it looks like in Microsoft Access. It's just a way that we came up with, using some of the other research and literature that was out there to describe the springs in New Jersey and the information that we had access to or thought was relevant to springs. And so this is what that geodatabase Ted talked about looks like. But basically this information is associated with a spring point or, points somewhere in New Jersey. Next slide. Right. So one of the other sort of other ways of characterizing them is sort of how they emerge. Right. So there's this whole terminology vernacular about describing how they emerge, and whether it's in a cave or whether it's in at the base of a hill or in a stream, kind of thing, or in a pool. And so we, described them when we did our site assessments, which I'll talk about next, sort of how they emerged, and then sort of descriptive. And again, some of them fit very cleanly into one of these, and some of them are sort of, they could be multiple ones depending upon how you look at them. Next slide. So here are limnacrine, sort of pool springs, mostly up in Sussex and Warren County. But this is typically what they look like. They're, coming into a lake or a pond. The one on the right is obviously a little man-made there, but the idea is that it discharges into a pool. Next slide. So these are sort of, at the base of a hill, the Raritan Springs, and just again, some examples of what they look like. Next slide. And then sort of hill slope. So at the break of a hill, this is what some of them look like, all the way from Sussex County, all the way down to Camden County, I believe. Crystal Spring is in. Next slide. Okay, so sort of how does this work? So Ted talked about we're continually adding springs to the database. You would get a report of a spring, whether it was a person, calling in, or someone talks to us, or a colleague saw something, or a newspaper report or something. We'd add the spring to our database, and we do a field visit if possible, and we would get some information from that site visit. That's kind of what we're doing. The two colleagues here are doing at this spring, and we'll go into the database. So the next slide. Right, so some of the sources that we talked about, right? So we're at NJ is Brow Kettle up there in Sussex, New Jersey. All geologic reports, old maps, newspaper reports, historical societies tend to have a lot of really good resources of ones that were sort of no longer known or no longer around. So a lot of different sources that we got. Next slide. Here's sort of our form that would take the site visit that you would fill out on a clipboard. or nowadays into a tablet, and you fill this out, and this information then would feed that database of information. So you've got discharge information, you've got geomorphic, emergence description, information, geologic information, any other cultural references. Was there a spring house? Was there a built pool? Was there something else around to it? And then some of the basic water chemistry results, temperature, color, odor, and some of the field parameters that we could test on site there that we could do relatively easily. Next slide. We did a little more deep dive, a little more study into Brow Kettle, which is the one up in Weird NJ, up in the Delaware Water Gap National Recreation Area. Actually measured some flow in there. And you can see here, this is the one that goes from empty to flowing at 4,000 or 5,000 gallons per minute, depending upon how wet and how high the water table was. So this is an interesting one, probably the subject of a whole nother talk and field trip kind of thing, but a lot of work that was done up here showing the variability of springs in both temperature and flow. Next slide. All right, I'm going to turn it over to my colleague Yari, who's a student up at Montclair, and we had the opportunity to collaborate through sort of a wetlands connection. And some of the work that she did was really interesting and really rounds out the view of springs. They're not just geologic, hydrologic, they're not just fish hatchery, but there's a lot of other, species and things that are going on there. So Yari, take it away.
Thank you, Steve. So good afternoon, everyone. My name is Jadi, and today I'll be talking to you about some of the work that I did specifically on macroinvertebrate assemblages in selected New Jersey springs. I'd also like to point out that this study was specifically for my master's thesis. And so next slide, please. Because it was for my master's thesis, the focus was for the purpose, we looked at how discharge and geology would be associated with the different spring sites. And thus, for this purpose, we selected some of our study sites from the 14 sites that Ted had described before. However, from the 7 sites that we selected originally, the last one that we see here, which is Blue Hole, we later on determined that we were going to exclude it from our data because it was not actually a spring. So our sites were a total of 6 and were scattered throughout New Jersey. They varied in discharge magnitude from 3rd to 6th discharge, and from geology. And geology we defined for the purpose of our study as carbonate versus non-carbonate. Carbonate we define as anything that the bedrock was composed of limestone, and non-carbonate was anything that was not composed of limestone, such as silt, clay, gravel, and sand. Next slide, please. So in order to collect the macroinvertebrates, we decided to collect for this purpose of our study from 5 different seasons, summer and fall of 2014, and then we extended to the spring, summer, and fall of 2015. Samples from each site were used from a transect, were composited into a sample, and depending on the habitat type, we used either a Hess sampler for stream habitat or an Ekman dredge for ponded habitat. And an Ekman dredge basically just takes a bite out of the sediment. Samples were then preserved in ethanol in the field and were brought back into the lab to be ID'd to the lowest taxonomic level possible. After identification, the samples were then verified by the staff at the NJDEP. In addition to macroinvertebrate sampling, the YSI multi-parameter SON was used to collect some water chemistry data, such as dissolved oxygen, pH, temperature, and conductivity, in order to complement our analysis later on. Next slide, please. So first off, I'm going to talk briefly about the results for the 7 spring sites, and then I'll focus on the one site, Valley Crest, that is in the upper Raritan watershed. From our 7 spring sites, a total of 2,526 individual macroinvertebrates were collected that encompassed 106 different taxa in 17 different orders. And something of notice was that no single genus or species of macroinvertebrate was found at all sites. Next slide, please. Now talking about the common spring macroinvertebrates, the most common orders were the dipterans, followed by the amphipods and the coleopterans. The chironomids, which are the midges, were found at all sites. One thing to note is that dipterans are usually tolerant very tolerant to pollution. Amphipods have a wide range of tolerance to pollution, and coleopterans are intolerant to pollution. For amphipods specifically, if we look at this picture, we can see that they have some eye spots, and I want you to note that because I'll talk about that on the next slide. Next slide, please. So I wanted to point out these taxa of notice, which were again found in some of the other sites in this study. So the first one is at the top right, which is a scud that was found in Dingman's Ferry. As Steve had mentioned before, Dingman's Ferry is a spring that has an emergence setting from a cave, and thus this scud is unique because it has adapted to habitat type and does not have these observable eye spots. There were 2 other taxa that were of notice because these were not in the NJDP master bug list. Now, this master bug list is just a list that the NJDP uses for routine monitoring of macroinvertebrates. However, this does not mean that these taxa have not been found in New Jersey or in the tri-state area. Next slide, please. So now I'd like to focus on Valley Crest, which is in the upper Raritan watershed. This site is in Hunterdon County. For the purpose of our study, this was classified under the carbonate geology. It has a narrow channel and it has a higher discharge magnitude. In terms of macroinvertebrates, only 2 seasons of data were collected. Data was not collected during the fall of 2014 and the summer and fall of 2015 because of low water quantity. So we were not able to collect the macroinvertebrates. In general, this site was characterized by high taxa richness, and taxa richness is just the number of unique taxa that were found. Taxa richness, if taxa richness decreases, as taxa richness decreases, then water quality also usually is an indicator of water quality decrease. High percent EPT. A percent EPT is percent of pollution sensitive species. And EPT then stands for the 3 macroinvertebrate taxa that are most sensitive to pollution, which include caddisflies, mayflies, and stoneflies. And then this would indicate that as this percent EPT would increase, then it would indicate water quality would also be increasing as well. And lastly, this spring was also characterized by having low conductivity. In general, low conductivity is suitable for macroinvertebrates to inhabit. Next slide, please. For valley crest, the macroinvertebrate composition was dominated by, similar to the general 7 spring sites, the dipterans and the coleopterans. In terms of pollution sensitive taxa that were present in this site, we find some taxa of notice, including mayfly, dragonfly, and green sedges. These were mentioned because of the pollution tolerance values, or PTVs, that are associated with these taxa. A PTV is just a number that is associated with each taxa that ranges from a scale of 0 to 10, 0 being the most sensitive to pollution and 10 being the least sensitive to pollution. So as we can see, some of the species, some of the taxa that were found in Valley Crest had very low PTV values, indicating that we're very sensitive to pollution. And one of the examples that I included here on the picture on the right is a taxa that has a very unique feature, which are these gills on the abdomen, which are plate-like. The presence of these plate-like gills are important indicators because they require a high amount of dissolved oxygen to be present in the water. And thus that indicates that valley crest would need to have high amounts of dissolved oxygen. Next slide, please. Now, I would just like to point out in this diagram, which includes the water quality parameters that were recorded, as well as the 6 spring sites that were included in the study, the similarities and differences between the sites. So to the right of the diagram, we see Valley Crest, which is a carbonate spring. And we see that it's very similar to SR and DF, which are also both carbonate springs. They are similar in terms of conductivity, having low conductivity, having high dissolved oxygen, and having neutral pH. And they are dissimilar to the other 3 sites, which are non-carbonate springs. Next slide, please. This next diagram is showing, instead of the water quality parameters, is showing the biotic metrics that were calculated. And these metrics then were calculated to just interpret the macroinvertebrate data and just summarize it into relevant biologic information, such as the percent EPT that I talked about earlier, which is just indicating the percent sensitive species. And with this diagram, I would just like to point out, for example, that Valley Crest and Dingman's Ferry are both carbonate springs and are both similar in terms of high taxa richness and high percent EPT richness, which are the sensitive pollution sensitive taxa. Next slide, please. And we ran some basic statistics in terms of the bedrock geology. We found that carbonate springs had significantly higher percent EPT values than non-carbonate springs, as well as the percent non-insects were significantly higher in carbonate springs than in non-carbonate springs. Next slide, please. So overall, we found that pollution-sensitive macroinvertebrate taxa were present in 5 of the springs that we sampled, which included Valley Crest in the upper Raritan watershed. Valley Crest also had a high number of taxa when compared to the other study sites. In general, carbonate bedrock correlated with better habitat conditions for pollution-sensitive species. And from our study, we found that springs were unique in terms of their water quality, water chemistry, and their macroinvertebrate taxa composition. They have important ecological significance, as Ted, Rachel, and Steve had mentioned before, and thus they are important to continue monitoring, as well as to continue to see the impacts of land use, land cover, and climate change trends. Next slide, please. I'd just like to acknowledge the NJDEP staff, Montclair State and New Jersey Center for Water Science and Technology staff, and friends and volunteers that help collect samples for this study. Thank you.
Thank you so much, Yari. Excellent. Well done. And thank you so much too to Rachel and Ted and Steve for presenting all of this fascinating information for us today. Really, this work in furthering our understanding of these freshwater ecosystems, I think it helps us get to better management of these systems. So really terrific, and thank you. And again, I will post in the chat the link to the full 300-page paper if anyone cares to dive in over the holidays and read the report in its entirety. So I would like to open it up to questions in the time that we have left. And I think we have Christy McDonald, our Director of Science, who's been monitoring the Q&A and the chat. Christy, do you want to bring up some questions, or I can turn off mute for anyone who would like to. Oh, here we go. Let's unmute Christy. There we go.
Hi, everybody.
There we go.
Hi. Wow, that was a fascinating group of people you had here today. I learned so much. Thank you so much. So I'm going to monitor the chat. If anybody has a question, just type it in. We're actually using Q&A, not the chat. We keep saying chat, but it's actually Q&A. So please ask questions.
I can kind of start us off. I have a number of questions. So I'm thinking about, I mean, we have many sets of standards, right, for water quality. We have, the Safe Drinking Water Act that dictates, public water supply, water quality standards, and we have, surface water standards and groundwater standards, and then the FDA has their bottled water standards. So I'm wondering if any of you can talk a little bit about, when we think about springs, what the standards are that we're using to assess water quality in springs.
This is Steve. Maybe I can take a general stab at that. So the study itself was really just characterizing, like what's there kind of thing. And so we took a sort of very broad brushed, basic field parameters. So pH, temperature, alkalinity kind of stuff. And then we had those 14 sites we were able to get some funding to do some additional additional water quality testing on, metals and VOCs and sort of broad range stuff. We weren't looking at them specifically for a drinking water perspective or a groundwater standard perspective, which sort of characterizing and assessing what they were. So the general takeaways that we usually get is that we found E. coli in all of these springs. So definitely don't drink them. Yeah. I know a lot of people do. Everyone's got their favorite spring that comes out of the side of the hill that they went to with grandma and grandpa or whatever. But generally we find a E. coli in all of them. And they're not monitored. There's no periodic testing, at least from the ones that are not bottled water. And then as far as the specific standards, I can't speak to them specifically about how the bottled water testing works or, versus the, the federal versus the local? Ted, I don't know, Ted, if you have any experience with that.
There's a section in the report about where spring water for drinking anyway, like is because there are some domestic water supplies that are from a spring in New Jersey, and I just can't remember off the top of my head exactly what it is, but it's in the report if you want to take a look at it.
Yeah. No, thank you for that.
Yeah.
It's interesting because they do, a lot of people do use springs as drinking water sources, but it can be very risky. So
yeah,
it's interesting.
it definitely has to be sampled if it's from a domestic source. So
I have a question. So you've got how many springs mapped out so far? I forgot. Was it 300 or more? It's probably more than that.
511 at the time of the publication of the report.
So how many springs do you think there are in New Jersey that just haven't been found yet?
Thousands.
Thousands.
Yeah.
So, okay. Yeah, because I know we have a spring on a site that we're worried about up in Roxbury that is being developed, and we think it's a contaminated site. You know about the site, Ted, their former Hercules site, and that wasn't mapped, even though it was on really old historical maps. It got erased from the more modern maps. So I have just a question. Is there any possibility of using GIS to find the springs, maybe using some sort of infrared or something that would show, like in the wintertime, maybe warmer temperatures coming out of the ground? Or is there just too much heat pollution out there?
Well, I'm in contact with the one of our drone pilots here, and they have a thermal camera, and it's something that we're thinking about doing if we can get permission to fly over the site to try and determine where those springs are at some point.
Oh, wonderful. Okay, so you're talking about doing that at the Roxbury site.
Yeah, and see if it works, because we haven't done this before. Steve can talk a little about. He's seen some studies on the Delaware River. Steve, you want to talk about what you were telling me earlier today?
Yeah, so I know. I think it's either USGS or the Fish and Wildlife Service did the same sort of drone flying temperature sensor to look at areas of cold water related to the dwarf wedge mussels, which they believe are associated with groundwater discharge sites. So they were using that difference between colder groundwater, or the consistency of groundwater discharge versus the either warmer summer or very cold wintertime stream temperatures, to try to look at that difference to identify areas. So I know it's been done in some places. I'm not familiar with what our drone capabilities are. And so to do a test case would make sense to see if it's doable. Ted, the only other thought I had to that was, if you're doing that, it might be ideal to fly over a known spring, so we know what it looks like, where we know where there's a spring here, what does our data look like? And then when you're using that, also to do a comparison of what you might see on this property, assuming we get permission to fly it.
Sounds good.
Okay.
Thanks.
Thank you.
And Yara, your work on the macroinvertebrate communities is really fascinating. I mean, that there are these unique macro assemblages in some of these stream sites. I think it may benefit us too to think about that when we think about our macroinvertebrate data in our stream monitoring program, and consider the source, or the spring source. If it's high calcium, high, if the source is karst. So I thought that was really interesting too.
Yeah, if I could just comment real quickly on that. It's true that, like, this project, while we only bit off a very small chunk of the spring world, it brought together Kathy Walls, a DEP wetland ecologist. It brought together Yari, a graduate student doing macroinvertebrates, Brian Henning, who's listed here, was a DEP fish and wildlife expert. And so we brought together these different, water quality, fish, macroinvertebrates, wetlands people, and we were all finding something unique at these sites. So, we found sculpin in the picture of the spring that Yari is standing in, and the fisheries guy didn't really expect to find them in that drainage basin. He found trout in places where they didn't think they would have trout, kind of thing. So it's really an interesting, even the small piece that we bit off of how these springs, are interesting geologically, water chemistry, and then all the other species that are associated with them. So it really does bring together a really broad group of scientific interests.
Yeah, that's work like this that can tie all of those together. It's really important. A lot of, we end up working in silos some of the time, but this type of work, it makes, it's great to make those connections. Well, we are past 3. Christy, did you see any questions in the Q&A that we should address before we close? Okay. Well, I just want to say thank you again to our speakers, and please extend our thank you to the other authors on.
Oh, wait, I'm sorry.
Oh,
Sorry,
okay.
there are questions. I'm so sorry. I didn't see them because I thought I was all the way at the bottom of the list and I wasn't. Okay.
Okay.
And we do have a few questions. I know, we're getting toward the end, but I will go back and look at the questions and we'll read them. And if anybody can stick around, that would be wonderful. We have one here from Emily Mayer, our very own watershed scientist. As far as historical records or resources, how many years did DEP go back to identify springs? What was the cutoff year?
There was no cutoff. We just went back as far as we could in any historical information we could find, old maps from the 1800s, newspaper reports, as far as back as we could go. So just whatever we could find, there was no cutoff.
Okay. We have a question here from Steve Foster. As a non-scientist, can a spring originate from an aquifer versus surface water finding its way back to the surface?
So this is they're very variable. It's not a clear definition. So like there could be a case where in the carbonate aquifers where a spring discharges and then it sinks back down to the ground and then discharges again, kind of thing. And so that may be what you're talking about. So they're very complex. Some of the cases are very complex hydrogeologically, particularly in the carbonates where you've got a lot of connection between groundwater and surface waters. I think technically, yes, typically they come out of the ground and they're in a surface water body and they stay there, but there can be probably cases where they go in and out. Particularly, you see that a lot out west when you have high elevation, where the snow melt comes out and infiltrates and then discharges, and then that spring disappears when it gets down the valley, kind of thing. The stream disappears again.
Okay. Another one from Steve. How might local landowners determine if their well house is a spring fed versus well or aquifer fed?
So by definition, where a spring is going to be discharged to the surface. So, if their source of water, it will probably be a spring house, so there's a house over an area that's wet, as opposed to a well, right, which is the hole in the ground. So there's a different construction there. So and then again, I think the other larger question is the water, it's one water, right? So it's either groundwater or surface water. Sometimes it's both, sometimes it goes back and forth. And so it just depends on the particular situation that you're looking at. But typically a water source for a landowner will be a well where there's a hole drilled into the ground with a pipe and a pump versus a spring house, which there are a few around. There's not many of them left that are used actively. We came across a couple in our studies, but most of them are sort of old historic, spring houses that were used, 100 years ago, just because of the risk from E. coli and contamination is high with those, so they're not often used.
Okay, we have a question from Dot Stillinger. She believes there is a springs layer in NJGeoWeb. Have any of your observations made it into that database?
Yes, we put that together from our research with this project, and we published that like a few years ago. Came before the report, So yeah, that was our work.
Okay, thank you. Samantha LaRocca, who is another person from RHA, she runs our well testing program, so has a great interest in springs and groundwater. Have there been any other studies of macroinvertebrates in springs?
Specifically in New Jersey, or?
I guess in the literature, is it common, or is it something that's kind of an area that is pretty new and you're?
It's definitely an area that's pretty new, but there are some studies out there. But it's an area of interest. Yeah. And in New Jersey, I don't think that I've found any other published literature on macroinvertebrates in springs. I did publish my study. This master's thesis is published.
Okay, quick follow-up question from me. Are you, is your PhD also going to be on the topic of macroinvertebrates in springs?
No, my PhD is on harmful algal blooms in freshwaters of New Jersey.
Okay, another important topic. We have a question from Keith Frishy with DEP. We have a lot of estimates of average summer stream temperatures in Northwest New Jersey that might indicate groundwater dominated streams. About 10 to 13 degrees Celsius average summer temperatures versus 20 in non-groundwater dominated streams. Just not sure at what downstream distance a spring becomes a stream. So looking forward to reading your report. Any comments on that?
It's variable. You know, it depends. You know, I don't think there's a clear definition, or we haven't settled on one yet. So you're right, when it comes out of the ground immediately, or is the spring channel part of the spring? I think it's open to debate and the questions you're asking. So right, good question. I don't know. we'll get there maybe.
Okay. And then we have Brian Lynch, who's just commenting that, you know, they also found American brook lamprey just downstream from what we believe is the spring on the Black River in Roxbury, which was an interesting find there too. Okay, and then Emily Mayer again, she's asking, are there future plans to continue mapping these springs or conducting further research on springs? Including eDNA, plants, macroinvertebrates, water quality testing.
So right now we continue to map when someone provides us with a spot to go check out and add to the database. That's ongoing. Right now there's no plans for any more studies related to the springs, but you know, that could always change. But right now it's not on the drawing board.
And
okay.
Who is the best person to reach out to if someone has identified a spring like on their property or suspects one? And would you be willing to provide your contact information so that people can reach out to you if it's one of you?
Yeah, it's me.
Okay.
Because yeah, I keep the database up to date. So
okay, great.
Please feel free.
Thank you.
Okay.
Okay, and one more question. Brian Lynch, who is also working on the Hercules site and found the brook lamprey up in Roxbury. How common is it for a spring to rise and vent from cracks in an otherwise confined aquifer?
I think somewhat common, right? Because the idea is that you've got a geologic control, which is focusing the groundwater discharge. So that you would typically, it wouldn't be a diffuse, if there was no confining layer, right? It would be a more diffuse kind of discharge. You might call it a wetland or something like that. So you typically have some sort of control, either it's a high conductivity zone or a low conductivity zone forcing discharge out of the lower, less, you know, higher conductivity. So yeah, that's part of the reason. The more extreme the differences are, the more likelihood that you'll have a spring and larger volume in a place with high conductivity.
Okay, thank you. There are no further questions.
Terrific. Thank you so much. And Yari, I may reach out to you so you can teach us how to use HESS samplers because those look fascinating. But thank you again to all of our speakers. I will be posting this presentation, as I mentioned, on our website under the Watershed Tools for Local Leaders seminars. series webpage, and there I can also post a link to the paper and contact information. If you know of a spring that may not have made it onto the map yet, you can reach out and let them know. So any questions also, feel free to reach out to me or Christy here at RHA. And thank you once again for joining us today. Have a wonderful afternoon, and please attend the next session. We look forward to having you again. Thank you so much.